In model rocketry, you're going to find there's two different types of propellant that are used. There's a black powder motors, which are characterized by engines that have a paper case, and then there's a composite propellant motor, which are characterized by a hard plastic case with a plastic nozzle. And this end that sticks out here is the nozzle end. This yellow end on the top, this is where the ejection charge is stored. Now the key difference between the two is the propellant formulation carried inside the motors. These use black powder, and these use a high-tech chemical formulation that's pretty similar to what's used in the space shuttle, which is why these are a bit more expensive, these composite motors over here. As far as performance goes, a D engine in black powder like this will release the same amount of energy as a D engine in composite, which is this one. The difference is the composite D engine is smaller, as you can see here. It's the same size as a C motor. The composite propellant releases its energy more efficiently than the black powder. So what you're paying for in composite is a smaller package inside the rocket. Let's take a look at the inside of a rocket motor. This is one that I cut open, and I don't recommend cutting rocket engines open. I wanted to show you the inside. Here at the end is the rocket nozzle. You can see it has the hole on it. And then above the nozzle, which is a clay, we have the black powder propellant, which goes from that area to that area. On top of that, the lighter gray composition is the delay charge. Now this is similar to black powder propellant, but it burns slower, just releasing a lot of smoke. And on top of that, and this is the front end this way, is the ejection charge. Now this is just loose black powder that's just held in place by the clay cap on top, and this is also fairly loose. Now black powder is very brittle, and if you take a big motor and you drop it, you can cause a hairline crack, and you wouldn't even see it. But that crack would be enough to, when the flame front hit that crack, it would burst open the case, releasing the rest of the black powder. If you open up a composite propellant motor, you would find the propellant looks something like this, and this is called a propellant grain. It's basically a slug of propellant. Now composite propellant is different from the black powder. It's pretty soft and malleable, and has the consistency of a rubber pencil eraser. This is nice because where black powder is brittle, this is soft, which allows us to make very big motors out of composite propellant. Where in black powder, about the biggest you'll ever see is maybe a D or an E size engine. And the reason for that is because if you drop it, it would cause a crack. But in composite propellant, you can pretty much have any size rocket motor you want, and this is the reason why they use composite propellant in the space shuttle. Here's a slug of black powder propellant ready to be burned. Notice how fast the black powder burns. Now here's the Aerotech Blue Thunder propellant being burned. Notice how slow it burns. And that's one of the major differences between black powder and composite propellant. The black powder burns fast, where the composite propellant burns slow.